Let's say we want to teach this robot how to make a perfect cup of espresso. A human could figure out a recipe, but a robot requires explicit, step-by-step instructions. We provide these instructions through code, which acts as the robot's brain. But before our robot can follow rules, it needs to keep track of its supplies. In code, we do this using variables. You can think of variables as literal storage boxes or pockets, where the robot holds on to its information. For espresso, our robot tracks two main ingredients, a starting variable of 300 milliliters of water and 50 grams of coffee beans. It also tracks money. We add a variable for the $5 handed over and another for the espresso's $3.50 cost. By keeping these numbers in its pockets, the robot has a clear picture of exactly what it's working with at every step of the process. Now the robot is ready to take orders, but it can't just hand out free drinks. It must verify we actually paid for it. To check this, the code asks a yes or no question called an if statement. Picture a scale. The robot checks, is the inserted money greater than or equal to the cost? It sees our $5 outweighs the $3.50 price tag. Because the answer to the question is yes, the gate opens, and the robot moves forward to read the next instruction on its list. In any piece of code, if statements act as security gates. The program only moves forward if a specific mathematical rule proves to be true. It comfortably passes both tests. With all permissions granted, the code prints a message saying payment is accepted, and the robot physically starts brewing the espresso. As it brews, the robot uses supplies. To keep accurate records, the code deducts 50 milliliters from the water, bringing the total to 250. It does the same for money, subtracting the espresso cost from our $5, generating a $1.50 change variable. By doing this math as it works, the robot ensures its internal count always matches the actual supplies left on the counter. But what would happen if we only paid the robot $2 instead of $5? Bringing back our logic scale, the robot checks if $2 is greater than $3.50. The math fails. When an if condition is rejected, the program falls back on an else statement. This automatic rule stops the machine, refunds the money, and prints an error. This same backup logic applies to the ingredients. If the water jug were empty, the code would fail the supply check and hit a different else statement, stopping the process before the robot tries to brew a dry cup. Making a smart robot works by combining these three simple layers: variables to track supplies, if statements to make decisions, and else statements to handle when things don't go according to plan.